Hey, hello guys, my name is Saddam and welcome to my channel. In this video, we are going to talk about Mathematica. First of all, I am going to tell you what is Mathematica. Mathematica is an application which let you do all the mathematical stuff what you want. For an example, 2 plus 3. 2 plus 3 will give you 5. Similarly, there are so many mathematical equations. For an example, you have quadratic equations, cubic equations, maybe derivatives, integral calculus, whatever it is, whatever you think, maybe plot, or maybe you want any kind of simulation. Everything you can do with using the help of Mathematica. So this application has name Wolfram Mathematica. The version I am using is 11.3. So here is the window. You can see here: file, edit, insert, format, cell, graphics, evaluation, palettes, window, and help. And here is a workbook. Okay, so in workbook you can write anything, any mathematical operation, and it will do with just simply pressing your enter or shift enter. Okay, so whenever you want something, you can write and you press shift plus enter. I know it is not visible to you, so we can magnify it. Go to window and magnification set to 150. So the thing is that how does Mathematica works? Here is a file and you can say just new book. So this is my new book, that is United 2. Okay, you can save here anything else. Now you can, maybe there are so many operations which we don't know, which you may not know. Then how can we understand all these things? Here is a help button and there is a Wolfram documentation. Now you go to Wolfram documentation and here everything you can find. Here you can find what is the code language. Code language means language overview, list, expression, association, variables. For an example, expression. What is the expression? Expression means full form, tree form, head, everything is there. For an example, common, general purpose. Everything you can find from this help button. For an example, I want to know what is derivative. So I will write here derivative. Okay, and just press enter. So it will give you the derivative. How to find derivative? For an example, it is a d. So what it's saying that if you want to find the derivative of, let's say, x to the power n, and here the variable is x. So what does it give? N x to the power n minus 1, as we know. Now similarly, there are so many functions with examples. It has given that how you can understand all these operations from here. So you don't need any kind of tutorial, but yeah, there are so many persons which they don't understand actually that how something operates. They need some help. That's why here is my video to help you out, to figure you out that how we can understand Mathematica and so on, so stuff. So let's just start it. I'm going to start with very simple thing. For an example, 2 plus 3. Again, I have to make 8 to 150%, and now you just press shift enter. So the output is 5. Similarly, I want to multiply 98 multiply by 54. Okay, here is a multiplication sign, 54, shift enter, and 5 to 92. Now here in this bar you can see here prime factorization, divisors, name, binary form. So far so good. So what does this bar do? This bar gives you suggestion that what you can do anything with this number, maybe prime factorization. What are the prime factorization? So these are 2 is prime, 3 and 7 and 2. These pairs can actually integer a factor of this thing. So this is the very interesting thing. Number of factors you can see plus at the right last number of factors. Okay, now number of primes less than 7, that is 4. Okay, how many primes are there which is less than 7? That is 7, that is 4. So there are lots of stuff you can do. For an example, let's say it is delete. Let's say I want to do 2 over 3, divide it. Now shift enter. It is not giving me any kind of value, that is 2 or 3, but I need some float number, that is decimal number. So what I do? Numerical value. So n of this parenthesis gives you this 0.67, but I want just only for 0.6, not these numbers. And what I can do? N of this thing, it means it is operating 2 over 3. Now comma, just 2-digit precision, it is giving you 0.67, it is 2 digit. Maybe I want to increase 3 digit, 0.67. Maybe I want to increase 10 digits. Now it is giving me this one. Okay, maybe I want 100 digits. Now this is the precision. I want to understand what is my pi. So I will write p in capital and I in small. This is your sum function. If If your argument is some kind of function, it will just become black. Okay, now if I am writing a, it is not assign any kind of function, so a is a. For an example, if I am assigning some value a6, now a is equal to 6 means a has the value which is 6. For an example, I am writing a and shift press enter, a has 6. A is equal to 9, now it has changed, the value of a becomes 9. So a is kind of a variable. Now when you are assigning something, for assigning we use only equal to, so it will get assigned, and whenever something is assigned already, then it will come as black. Just like n, for an example, you want to sign that maybe n is equal to, I want to write 54. Can I write it? Now here is said that set symbol n is protected, means that you cannot assign anything to n. Then how we can do it? We can write na. So na is equal to 45. Now na is your variable and you can write easily 45. Now I can call na times a. Okay, what is this? 45 into, because I have the value of a is 9. 9 into 45 gives you this 405. So this is the way we can do it. Now for an example, n of pi. So what is this pi? We can say pi. What is this? Pi is simply, this is 1 pi. But I want pi in terms of degree. So d of n something degree, 180 degree. Now I want multiple of pi. So it is pi. Express as radians 3.14159. So I can write maybe 54, 45 precision. This is your 45 precision. 450 precision. This is the 450 precision. Now 45,000 precision. Now you can see here all the numbers are here. Okay, so this is the way we can do all this thing. Now this number this much big and just blink of the eye. So this is operating in 1 by nanoseconds. Okay, so this is too much fast. That's the interesting thing about Mathematica, that it is insane fast. It can do anything. For an example, what it can do, let's write d for derivative, and let's say x to the power n. Whenever we have to write in terms of x to the power n, we write as this is. Now what is my variable? My variable, let's say x. So function will go this side, and after comma there will be your variable. Now again this one, the bracket is closed, operation n x to the power n minus 1. Okay, now again we can do, for an example, let's say your n is now function of x. Okay, it can be. So whatever your power is a function of some kind of x. Again, then what happens? So here it is, x to the power nx, nx over x plus log x n to the power x. So what is this n dash? N dash x is dn over dx. So we can write here that it is nothing but dn over dx. So this is the meaning of n dash, n prime of x. So n prime is equal to nothing but dn by dx. So this is the interesting thing. For an example, it is a complex thing, maybe sine. So if you write sine this way, and whatever the argument of sine may be angles and so on, it will come like this. The function is x. So cos of x, maybe this is your cos, then what will you do? Cos of x minus sin x. So these are the interesting stuff you can do with Wolfram Mathematica. So this is really need to understand. And one more thing I want to tell you, that this Wolfram Mathematica, this is an industrial version. Okay, industrial means that this application is designed in such way that in industry people use it. So for research purpose, I use this application too much, and I think it is a very interesting software to learn, because if you are doing any research or if you are doing any kind of heavy project, this will help you a lot. Well, so let's start with some basic stuff. For an example, what is the basic stuff? Let's say simplifying it. What do you want to simplify? I want to simplify, for an example, x to the power a plus b x to the power squared plus c x comma y into z to the power 32. So can it simplify? Yeah. Simplified means that it has some kind of a very simplified equation. So I don't have right now any equation, but if you have some crazy equation, it will give you some simplified method. For an example, let's say a by b plus, a is my protected. So how we can clear something? So if my a is already assigned, just type clear parenthesis and it will clear you. Okay, so it is a very awesome thing. Now we can just write simplify some equation like a over, let's say, b plus x y. Okay, so xy is another variable, and then again c over z, and again I can write here just one parenthesis z over x plus y by a, and boom. Yeah, okay, now simplify it. So this is a simplified manner. So here it is. So that's why Mathematica is awesome, because by using Mathematica I don't use any kind of thing. For an example, you don't know integration. Okay, what I can do here, INTEGRATE, integrate. Okay, I want to integrate what? Sine of x. Okay, sine of x, just integrate with respect to x. What will happen? Minus cos x, I know it. Now sine of x square, what will go? Oh my god, this is fractionals. If you will solve this equation, it will take you hell amount of time, but here you can easily find it out. What is this? Now you can easily plot it also. So that is the beauty of it. Maybe sine of ax. Okay, you always understood, wow, cos ax over x. Maybe sine of 3x, what will happen? Minus 1 by 3 cos 3x. Okay, so in 12th standard or in maybe in our undergrad, we are learning everything, that how to integrate, how to differentiate, and so on and so forth. But using Mathematica, it will just give you a blink an eye. So it is this way we are doing it symbolically. It is not giving you something like, okay, fine, it is giving us only numerical result, but it will give you everything about that, how it is actually done in symbolic form. Maybe sine x over x, what will give you? Sine of integral x, because this integral is not capable of doing it. Maybe for an example, we need some domain to actually do it. So for example, if I want to do it in this thing, I want to write n integrate. Okay, this n integrate means numerical integration. Numerical integration, do sine of x over x, x1 comma 2. For an example, I want to do from 0 to 2, it will give me. Maybe I want to write minus 1 comma 2, then 2.15515. Now what the hell has happened, that if I want to integrate sine of x in terms of x, sine integral x, okay, so it will give you just some cool stuff. For an example, cos x, half sine integral 2 of x. So we can expand it. Maybe I want to understand what is this information. What we can do, I don't want to copy it. I don't want to copy output number 4. What we can do is percentage 44. Okay, now it is not giving me anything. Okay, so now I can write full simplify. I want full simplify, again percentage 44 output. So this is nothing, it is not giving me anything. So but there are very simple interesting thing that yes, there are something we can expand. For an example, expand my a plus b to the power cube, and now expand it. Here is your expansion. Maybe a plus b plus c to the power cube, this is your expansion. Now plus d, expand it. Now this is your expansion. Now I want to full simplify it. So what happens if I am writing full simplify? It is not giving me anything. The full simplify gives you the compact form of anything. For an example, if I write to expand it, let's expand this. Am I too fast? I don't think so, maybe. So what I can do is, we can write full simplify. Okay, full simplify, and then output number 51, just this one. So full simplify will erase everything, whatever it is not just writing it anything in elaborative way, but it is compactifying things and giving you the precise result like ab plus cd to the power cube. Maybe I want to do it for 4, this is thing. So you want to understand that, okay fine, I don't understand this too many equations. What is this for? Wow, amazing. Do you know the 5th equation? No, this is your 5th equation. Maybe 10th. Wow, what a beauty. So this is the very interesting stuff with Mathematica, that it will give you the symbolic way of doing it, and that's why I like it. That's why I like it. So there are again so many things. For an example, if I am having some equation, for an example, simplify x to the power squared plus 1 plus maybe I think what is this x 5x, okay, it is 5x plus 30 is equal to 0. So when you are putting this double equal, then it doesn't mean that it is equal, okay, otherwise it will not do anything. So if I am writing it, this is only giving me the true, that x square plus 5x plus 30 is equal to 0, then x. What we have to do, it is not simplifying it. I don't have to write simplify, I have to write solve for this equation for x, if x is in a variable. So now you have these two equations, because you know this is a quadratic equation, therefore I can have these two solutions. Now let me change here minus 30. Let's see what's the result. Now this is the real result. Now maybe you are interested in numerical values, so numerical value is minus this one and plus this one. Maybe I am also interested in this one, okay, there is no any problem. Maybe it is 100, so numerical value is minus this one and this one. Now you want to solve that, okay fine, I need again numerical result in, I don't want any kind of this kind of format, so just write it here, simple, okay. Now maybe it is your 200, this one, maybe it is your 10x squared, this is, so n of this one it will give you similarly, not in an expressive manner, but this one, okay. Let's maybe this is your a and this is your b, okay, in expression. Yeah, this is my expression for it, okay. So that is the beautiful thing in Mathematica. It is not a calculator, it has powerful AI, which is we call artificial intelligence, and based on the artificial intelligence it is deciding that, okay fine, how things are going to happen, how something will be calculative, okay, and based on this it is actually working. So thank you so much.